Hello students. So welcome back to lecture 2 on module 2, and we'll start in this lecture from ring rolling where we have left in the previous lecture. So ring rolling is used for tube rolling to manufacture not to manufacture, to roll the tubes. Now understand the difference here. The product which we are going to take, or we are going to use here, that will be a tube. So we will not manufacture tube here, but we will do some modification or some, like improving the surface finish or increasing the diameter of the tube or decreasing the thickness of tube. So that kind of task we will do here, but we will not manufacture the tubes here. Okay, so as you can see in this diagram, look at this diagram. So this is a tube. Let's suppose whose thickness is initially some t. So after rolling between these 3 or 4 rollers, we will decrease the thickness of the tube. So that's known as ring rolling. Now come to the next question. That's see this question. This question asked in ISRO 2009. So he's asking that ring rolling is used for what? So answer is A. So ring rolling is used to decrease the thickness. जो ऑलरेडी ट्यूब है हमारे पास उसका थिकनेस कम करने के लिए, और जब थिकनेस कम करोगे तो ऑब्वियसली डायमीटर और लेंथ कोई एक चीज़ उसका इंक्रीज होगा, तो यहाँ पर उसका डायमीटर जो है वो इंक्रीज होता है, कीपिंग द लेंथ एज ए कांस्टेंट. सो उसका थिकनेस कम होगा और डायमीटर उसका इंक्रीज होगा. Now see the sheet rolling. So in sheet rolling we are only attempting to reduce the cross-sectional thickness of material. So sheet rolling में क्या होता है, जो शीट अपने पास है उसका हम थिकनेस जो है वो रिड्यूस करते हैं और उसको रोल कर लेते हैं. एक एज यू कैन सी इन दिस डायग्राम, उसको एक बंडल की फॉर्म में रोल करते हैं. सो यू कैन सी हियर. सो दिस इज ए शीट विथ रिड्यूस्ड thickness. Now roll forming, this is something important, as the name indicates, forming. Okay, so our roller will be having some form on it, and that form will be the form which we want on the billet or blooms. So look at these pictures here. We need a cross-sectional area like this. Like this. So it is not square, but a small chamfer is there at the midpoint. So if you need a cross-sectional area like this, then we must have our roller in this form. Now look at this cross-section. Another cross-section, that cross-section is something like this, that second one. So if you want to get this kind of cross-section, then our roller must have some forms on the periphery of it, and that form must be like this, so that we can get the product with this form. So this is known as roll forming. So now look at roll bending. So in this case, by using the rollers, we will bend the product. So total 3 rollers will be required. 2 rollers will support the product or sheet in one side, and another roller will support in the another side. So total 3 bending rollers will be required. So you can see in this picture. So look at this picture, how you can roll a sheet or any steel or any metal member using 3 rollers. So this is known as roll bending. This is known as roll bending, and this is roll forming. In this roll forming, rollers will be having some foam on its periphery. Now look at this question. Which one of the following is a continuous bending process in which opposing rolls are used to produce long sections of formed shape? Long sections of formed shape from a coil or strip of a stock. So as he is mentioning that opposite roller is used for the use of long section of formed shape, then what kind of rolling process is this? So this will come, as he is not mentioning about any forming process, he is mentioning about bending. You can see here bending, continuous bending process in which forming is also there, long section with formed shapes. So such kind of process is known as roll forming. So this is roll forming, in which we have seen some forms on the rollers. Now you may wonder like why this is not roll bending, because it's mentioned that this process is already a bending process. So bending is already there, but to get the formed shapes on or from coil or strip, he's asking to get the form shapes. So to get the form shapes, we need some forms on the rollers, and that process is known as roll forming. Now what is peck rolling? So it involves hot rolling of multiple sheets. What happens here, like suppose we are having some different layer of sheets. So now we will roll these layer of sheets between the rollers. So we will roll these multiple sheets, and these sheets are uh, separated by a thin surface of oxide film, so that they should not get stitched or they should not get welded. So such kind of rolling process is known as peck rolling. Now in thread rolling, we are having some uh, thread forms on the rollers, and our um, workpiece will pass from these rollers or between these rollers, and then threads will produced on the workpiece. So it is used to produce threads in substantial quantities. This is a cold forming process. Now this is very important. बहुत बार जो है ये एग्जाम्स में पूछा गया है कि थ्रेड रोलिंग प्रोसेस जो है वो हॉट रोलिंग होता है या कोल्ड रोलिंग होता है. सो इट इज़ ए कोल्ड रोलिंग process. Why it is not hot rolling process? Because we will not be able to maintain the close dimension in case of hot rolling. So surface finish भी अच्छा नहीं होगा, close dimension भी नहीं होगा. And we also remember that hot rolling is followed by annealing process. क्योंकि hot होता है, उसको आप उसी टेम्परेचर पर छोड़ दोगे तो वो रिकवरी, रिक्रिस्टलाइजेशन एंड ग्रेन ग्रोथ फॉर्म में जाएगा. That will increase the ductility and reduce the hardness. So हम नहीं चाहते कि इसका hardness या strength जो है वो कम हो, ductility increase हो. So is this clear? So no metal is removed. Obviously there will not be any metal removal process, and this is simply a getting some form of a thread on the workpiece. So look at this picture. This is how we can manufacture the threads on a workpiece or threads on any bolt, we can say. Now we can also manufacture the gears. So how we can manufacture the gears? Look at this picture. See this picture. So here this is one roller and this one is another roller, and between these rollers we will pass our workpiece. Now by giving axial pass to the workpiece, we will also give rotation to the workpiece, so that we can get the teeth on the surface. So you can see here teeth are there. So you can see here teeth are there. Now roll piercing. So roll piercing is a process in which our mandrel, we will use one mandrel. This part is known as mandrel, and this is roller 1 and this one is roller 2, and roller 1 and roller 2 will be inclined to each other. So if suppose this is the axis of roller 1, then this will be the axis of roller 2. So you can see in this picture, these are not, it seems like it is horizontal, but this is not horizontal. This end is going out this side, this end is going out, and this end is coming towards our side. So it is at some angle. So you can see here it's a variation of rolling, and that's called roll piercing. And the billet or round stock, the billet or round stock is used between two rollers, both of them rotating in the same direction with their with their axis as at an angle about 4.5 to 6.5 degree. So see, the angle is about 5 degrees there, and they both rotates in the same direction. So what happens over the sheet that we will be using, that will get rolled, and by rolling that sheet we will be getting a tube. So this is what roll piercing process is. Now you can see here, this is a different type of rolling process. If you are using two rollers, then the names which is given is two high non reversing rollers. Now in this case, two high reversing rollers, you can reverse the direction. Now here this is total 3 rollers and 2 workpiece are there. So you can get the good production here. And this is 4 high rolling process. So this is to avoid the bending in the rollers due to cold working. So generally these two processes, that is cluster and 4 high, that will be used for cold rolling. So this is important. Remember, this will be used for cold rolling. Now let us see one video on roll piercing. Let me check if I have opened that video. Actually I have closed the data, so this might not work. So let me on the data here. Now look at this. This process is an example of extrusion process. You will see in the coming lectures. This is how we can manufacture the tubes.
Von der Lochpresse geht das Lochstück zum Schrägbalgwerk. Zunächst wird der von Lochpresse verbliebene Boden mit einer Kraft von ca. 3200 kN durchstoßen. Anschließend wird das Lochstück im Schrägwalzwerk vorgewalzt und zum dickwandigen Hohlkörper, dem Hohlblock,
So this is
ausgestreckt.
the process of manufacturing the tubes. Now we'll show
Der Block wird in
roll
das
producing
Walzwerk
process after
eingestoßen,
this one.
im konischen Einlaufteil von den Walzen erfasst und in Schnürung in der horizontalen Ebene, eine Aufweitung in der vertikalen Ebene.
Now look at this process, how this tube is rotating.
Der Trick verdeutlicht das Verfahren. Das Schrägwalzwerk besteht aus
this is
zwei
the
besonders
manual and
profilierten Arbeitswalzen.
Look
Sie werden im gleichen
how you
Drehsinn
can
angetrieben.
manufacture the
Ihre Achsen sind gegen die
hollow
horizontale Walzgutachse um etwa 3 Grad geneigt. In der Mitte des Walzspaltes befindet sich als Innenwerkzeug ein Lochdorn, der über eine Stange an einem außerhalb liegenden Widerlager abgestützt wird. Die Wanddicke des Hohlblocks wird reduziert und egalisiert und der Außendurchmesser je nach Bedarf vergrößert oder verringert.
hot rolling process, then you get such type of
Die
video.
Streckung des Materials beträgt dabei etwa 1,5 bis 2.
So let's come back to our presentation. So from here we will start in next class, as we are already moving to the end. So I would like to conclude here, then we will continue from here in the next class. Thank you. Have a good day.